arc length, linear speed, and angular speed. So for arc length, for a circle of radius r, a central angle theta intercepts an arc of length s given by the formula s equals r times theta, where theta is measured in radian. Now I know you would have calculated arc length probably in degrees in geometry, but we want to stick to theta as being in radian because we're really going to need that for when we get to angular speed a little ways down in these notes. So if you take a look at our circle, you see that we have 2 radii written there in red, and our angle is theta, right? It's kind of looks similar to the angles we've been drawing. And S is pretty much how much of the circumference is being used. So also note that if R is equal to 1, if the radius is 1, then that makes our angle and our arc length equal to each other. And that's the beauty also of using radians here, that we see those numbers being the same. So let's take a look at a few examples. The first one says a circle has a radius of 4 inches. Find the length of the arc, or S, intercepted by a central angle of 240 degrees. So the first thing that we're going to want to do is convert that 240 degrees. We don't want to use degrees. We want to use radian. So if we think about where 240 is on our unit circle, 240 is the same as 4 pi over 3 radian. So now we're in good shape. So we're looking at our circle, right? We have our radius, or we have our center. We have our radius at our initial, and then we have it down here at about 240, and here's my angle for that 240, or that 4 pi over 3. So what we're asking for is, what is this arc length? What is that? So we're going to plug into our formula. We know that we have S is going to be equal to R times theta. So let's put in the information we know. We're looking for S, that's the question. So we don't know what S is, but we know that the radius is 4 inches. That's what they tell us in the directions. And we know that the angle is 4 pi over 3. So all we have to do is that multiplication. That's going to give us 16 pi over 3. So S is going to equal 16 pi over 3 inches. Or if you wanted to convert, that's like 16.76-ish inches. Using the same concept, if we have a circle of radius 27 inches, we want to find the length of the arc, so we're looking for S, and we have the angle 160. Again, we want to look at that at radians. We don't necessarily know that one off the top of our head, but we can use our little conversion. So we're going to multiply by pi radians over 180 degrees. And when I do that math, that's going to give us 8 pi over 9 radian. Okay, so I have my circle. 8 pi over 9 is going to be in that second quadrant. So, whoops, I have my radius here, 8 pi over 9 somewhere over here. Here's the angle, 8 pi over 9. And I'm looking for this arc length. All right, so we know that arc length is going to be equal to R times theta. So we're just going to use the given information. So we don't know the arc length. That's what we're searching for. R here we said is 27 inches. And then we're going to multiply by our angle in radian. That's 8 pi over 9. And when I do that multiplication, I'm going to get about 24 pi. 24 pi. And that is in inches. Again, we could calculate that out. That's 75.4 about. Okay. The next thing I want to talk about is linear speed. So what linear speed is doing is measuring how fast a particle moves. For example, if we had a car, right, and we're looking at the tire, and the tires are rotating as we drive, think of this linear speed as measuring how fast does, say, does this particle move. So if there's like a rock in my tire, how fast does that rock move? Okay. So what we want to do is take a look at a formula here. So V for velocity, right? Linear speed. And we have the arc length divided by the time. Okay. And when we say time, we mean time that it takes to complete one revolution. In other words, time that it takes to go completely around the circle. How long does it take to move completely around the circle? All right. So we first need S, and then we're going to divide that by the time it takes. So it says in our first example The second hand of a clock is 10.2 centimeters long. That's going to act as our radius here. So this is really my R. Find the linear speed of the tip of this second hand. So the other thing we're going to need is our time. Time is going to come from how long does it take for the second hand to go all the way around a circle? Well, that's pretty simple. How long does it take a second hand to move a full clock? 60 seconds. So our time here is going to be 60 seconds because that's how long it takes it to go all the way around the circle. All right, so let's find our arc length, and then we'll find our linear speed. So S is going to equal R theta, and we know that R is going to be 10.2. Our theta, we know we're looking at 2 pi here, and the reason we know we're looking at 2 pi here is because we're talking about it going all the way around the circle, and an entire circle is 2 pi. So that means that we're looking at really 20.4 pi and then centimeters. All right, so there's our arc length. We know our time is 60 seconds because that's how long it takes to go around the circle. So lastly, we need to figure out what is going to be our linear speed. So our linear speed, or our velocity, is going to equal, we said, S over T. So we're just going to put in the information we know. We just said that S was 20.4 pi centimeters. And we just said that time was 60 seconds. And really what makes the most sense here is then to just switch back over to a decimal. Forget about the pi because of how messy this is going to be. So this is going to give us about 1.07 centimeters per second. So what that means is that particle, or that second hand, the edge of the second hand, like the little arrow on it, it takes 1.07 centimeters per second. That is the speed at which it is moving. All right, so here's another clock that's a different size. This clock is a little bit smaller, and it is only 8 centimeters for the second hand. So that gives us a radius of 8. Again, we want the linear speed. So again, we're talking about how the second hand moves. So our time is still 60 seconds because that's how long it takes to go completely around the circle. And again, our angle is 2 pi because we're talking about going completely around this circle. So we need our arc length first, and then we'll find our linear speed. So we have R times theta. All right, so we know that our R is going to be 8 centimeters. We know that our theta is going to be 2 pi. So that's going to give us 16 pi centimeters. Last, we need our velocity. So our velocity is going to be equal to S over time. So the arc length over the time it takes. So that's going to give us, we said S was 16 pi centimeters. And our time is 60 seconds. When we do that division, we're going to get about 0.8378 centimeters per second. Okay, so there's our velocity. All right, and lastly, angular speed. So angular speed measures how fast the angle is changing. So when we're looking at this, we're looking at omega instead of, even though it looks like a W, it's the Greek letter omega. And we have a central angle divided by the time. So the central angle, again, we want to make sure we're measuring in radian. So let's take a look at some examples. So our first one is a 15-inch diameter tire on a car makes 9.3 revolutions per second. Okay, so first of all, we haven't been talking about diameter at all. We've been talking about the radius. So let's convert that real quick into a radius. So we're going to cut it in half, and that'll give us 7.5 inches for the radius. We're going to hold on to that for later. We don't need it just yet. And then a car is making 9.3 revolutions per second. We want to find the angular speed. So in order to find the angular speed, that's going to be omega is equal to the angle divided by time. Okay, so we need to find the angle, and then we need to find time, right? So in order to find the angle, what we're going to do is figure out how many revolutions we're moving, and then we're going to multiply that by 2 pi. Every revolution is 1 time around the circle. So 1 revolution equals 1 full circle. And that's why we're multiplying by 2 pi, because that's how much radian is 1 full circle. So that's going to be 9.3 revolutions times 2 pi, and that's going to give us 18.6 pi radians. Okay. All right, so we're going to use that information. We have 18.6 pi radians. The time we're looking at here is how long does it take for us to move that many radians. So we're moving for 1 second. Okay. And then we're going to make that division, and it's going to give us obviously 18.6 pi radians per second. All right, so the next thing we want to do is look at the linear speed. So when we're talking about linear speed, it's really velocity, and that is going to be the division of the arc length divided by the time. All right, so the arc length that we have here is really going to be calculated again by r times theta, and the radius, luckily, we had just before. All right, so our radius we said was 7.5 inches. We just calculated our angle to be 18.6 pi. And then we're going to divide by the time, which is 1 second. And when we multiply that out, what we are going to get is about 438.25 inches per second. In our next example, a circular blade on a saw rotates 2,400 revolutions per minute. So we want to find the angular speed of the blade in radians per second. So let's just make sure we are converting the radians, revolutions per minute into seconds, so we're all in the same units here. So if we have 2,400 revolutions in 1 minute, really that means we're moving 2,400 revolutions in 60 seconds, because that's equal to a minute. But let's simplify that, so we're looking at just 1 second. So that's going to give us 40 revolutions per 1 second. So all we did was just convert that to seconds instead of minutes. Now what we want to do is find our angular speed. All right, so our angular speed we know is omega is equal to the angle divided by time. So we have our angle, whoops, that's supposed to be theta, divided by time. All right, so we need to calculate the angle. Remember, the angle is going to be revolutions times 2 pi. So our revolutions were 40 times 2 pi. So that means our angle is 80 pi radians. What is the time that takes? That is 1 second. So when I make that division, I'm going to get 80 pi radians per second. All right. And then lastly, our linear speed. So our linear speed velocity, V, is going to equal the arc length divided by time. Oops. Need to scroll just a touch. The arc length divided by the, oops, there we go. Divided by time. So arc length is the radius times theta. And time. All right, so they tell us that our radius is 4 inches. So this is going to be 4 inches times the angle that we just said was 80 pi. And we're going to divide by the time, which is 1 second. All right, when we do that, we are going to get, that's going to be 320 pi, which is going to give us about 1,005 inches per